Okay, this is the P1 paper from June 2023. It's question number 10, which is the last question on the paper. And as we can see, this is chapter 5, straight line graphs. In particular, we're going to be looking at parallel or more likely perpendicular lines, and we're going to be trying to find some equations of those straight lines. So let's have a look at all the information. So it tells me figure 5 is a sketch of the quadratic. So this thing here is given by that function there. It also tells me we've got line L1, and that's got gradient of a half, and we can see that it intersects with C on the negative axis here and at the point P there. I will go through the rest of it, but that's enough to be able to do part A. Part 1 says, write down the equation for L1. So I'm going to try and find the equation of this line. So if I want the equation of a straight line, it would be great if I knew the gradient, which I do, that's a half, and if I knew a point on the line. Now I know 2 points on the line, but it's actually this second one that's going to be more interesting to me, because I can see that that point there is also where this curve hits the x-axis. And if the curve hits the x-axis, then I know that's going to be when y equals 0, and I can use those two bits to try and work out what that's going to be. So let's have a look at all that. Let's write everything down for the examiner, so the examiner knows exactly what I'm going to be doing here. So part A. Part 1, for line L1. Well, I know that M is equal to a half, and I want a point x1, y1, and what I'm going to do is work out that point there. Because it's where it hits on the negative, that's going to be where x plus 2, x minus b is equal to 0, which will give me x equals minus 2 or x equals b. So that value there is minus 2, and later on if I need it, that value over there is going to be equal to b, and it's the x equals minus 2 that I'm going to work out. So actually, I now know that the coordinate at that point is minus 2, 0 in there. So let's take that working and put it as part of my answer. If x minus 2, so x plus 2, x minus b is equal to 0, then x equals minus 2 or x equals b. Therefore, x1, y1 is the point minus 2, 0 here. And now I can work out the equation of straight line. So equation of straight line, should have done this lots and lots of times. Part of your revision. Y minus y1 is equal to x minus x1. I always tend to write these down in the same sort of way. Here I label what I've got. M is equal to a half, x1 is equal to minus 2, and y1 is equal to 0. So if I put all that information in, I get y minus 0 is a half, x minus minus 2, so that's x plus 2. Well, that's going to give me y equals a half x plus 1 by just multiplying out that bracket. Let's just go back and check. No, it didn't say anything about the way it wanted that written down, so that's absolutely fine. Now for part 2, it says, can we find, in terms of B, the coordinates of P? So I want to work out this point here. Now the key thing about this point, or one of the key things about this point, is I can see this is where L1 meets the curve. And if it's where L1 meets the curve, I can solve that algebraically. Let's explain to the examiner what I'm doing. So part 2, I'm going to say for P, L1 meets the curve C. So in other words, half x plus 1, that's the equation for line L1, is going to be equal to minus a quarter x plus 2 x minus b. Now all I need to do is to see if I can solve that. So I'm going to just change my half x plus 1 and write it the way I had it just a second ago. That is half x plus 2. from up there, half x plus 2. Why am I doing that? You'll see in a second that if I do that, it's just going to save me a little bit of time. X minus b here. I can then cancel those two out. So it's a nice quick method for tidying all that. So I'm going to get a half equals minus quarter x minus b, and now you can just tidy all that up. So take the minus 4 over to the other side. We're going to get minus 2 is equal to x minus b. So in other words, x will equal b minus 2. That's sort of that handwriting there. X will equal b minus 2. And it said to me in the question, can I have x in terms of b's? So yeah, I've actually solved that. Do I need to? Yes, I do. I also need to find the coordinates, so I need to find the y value, so I'm not quite finished yet. If I want the y value, y is equal to, let's just put that back into the equation, half, well, x plus 2, isn't it? That was the equation of the straight line, so that's going to be a half b minus 2 plus 2, well, that's going to give me half b. So y is equal to b over 2. So coordinates are b minus 2, b over 2. That's the coordinates for point P. Okay, quite a complicated question this, but it is question 10, so it's not surprising it's a little bit more difficult. Given that the line L2 is perpendicular to L1 and intersects on the positive x-axis, yep, we can see all that information there. Find in terms of B an equation for L2. So if I want an equation for L2, just like last time, let's explain what I'm going to do here. So this is part B. For L2, I want the gradient. Well, the gradient will be minus 1 over the gradient of L1. So minus 1 over a half gives me a gradient of minus 2. And I want a point x1, y1. And we know x1, y1, we can use the point B0. I'm using that point there. So now that I've got all of that, sorry, a lot of moving up and down with the screen here, but I can't really help that. What we've got then is to put that information in. So y minus y1 is going to be equal to m x minus x1, and I know that m is equal to minus 2. I know x1 is equal to b, and I know y1 is equal to 0. So subbing all that in, y minus 0 is going to be equal to minus 2 x minus b. So in other words, y equals minus 2x plus 2b. So part B done. Part C, it says, given also that L2 intersects C at P, which we can see it does, it intersects at that point there, can we show that another equation for the line L2 is going to be given by y equals minus 2x plus 5b over 2 minus 4. So let's just find another way of looking at that. So let's just show you then. So if I'm trying to work out the equation of this line, again, I know the gradient is going to be equal to minus 2, but rather than using that as a point on the line, I'm now going to use that as a point on the line. So a lot of work using the same formula, but just in various different ways here. So for part C then, an alternative for L2, I can say m is equal to minus 2 like it was last time, but this time x1, y1 is going to be p. So y minus y1 is equal to m x minus x1. So I've got m would be minus 2, and the point for p, x1 is b minus 2, remember, and y1 is b over 2. So let's just sub all that information in. Hopefully it's just going to pop out as the answer here. Y minus b over 2 is equal to minus 2 x minus b minus 2. So minus b minus 2 would be minus b plus 2 there. I'm just looking at the answer here to see if I can just mold that out. I think if I just multiply out the second bracket here, I'm just going to get minus 2x plus 2b minus 4 there. And then if I just take the b over 2 over to the other side, it's minus 2x plus 5b over 2 minus 4. And if we look at that, that's what we actually had for part C anyway. And then it says, right, hence or otherwise, find the value of b. Well, we've now got two alternative equations for this straight line. We've got this one here and this one here. So we can just put those two equal to each other for the last part. Part D, if I get that minus 2x plus 2b is equal to minus 2x plus 5b over 2 minus 4, and then we've just got to tidy all that up. So I'm going to get that 2b is equal to 5b over 2 minus 4, which is going to give me, I'll let you work it out, b works out to be equal to 8 when we rearrange all of that. So yeah, quite an interesting question, that one. It's a question 10, so it's okay for it to be a little bit more difficult, but lots of use of y minus y1 equals m, x minus x1. Hopefully that all makes sense to you.